Howdy, ZIO world. My name is Kit Langton, and yeah, just firstly, well, I worked on the ZIO magic thing that so many people were so nice to talk about earlier, and I hope by the end of this talk I can convince all of you to um, delete it. We'll see why. No spoilers, but stick around to the end. I'm very excited. I'm also excited to announce that I work for ZyBridge now, which is probably inevitable. Um, yeah, ZIO's just been amazing. I didn't really like Scala much until I found it. I came from Haskell and I was searching for something that, you know, just fused this idea of a deep understanding of functional programming, but then also usability and, well, ergonomics. I actually started in Ruby and Ruby on Rails, which certainly has that world. All it has is usability. It doesn't have type safety or anything. So ZIO to me is on this frontier, something that I've been wanting to exist for a while, which is this intersection of like a deep understanding of category theory. These are some heavy hitters. They know their stuff, yet they also have ideas of usability and design, which is a huge part. Like these programming languages are written for people. Okay, that was off the top of the head. Back to the slides. I'm actually about to work for ZyBridge. I don't work there yet, so in due time, maybe by the time this video is released. So this talk is officially free of bias, so you can take everything I say completely objectively. So just know that. So ZO2 ergonomics. As John hinted in his introduction, this does indeed concern some potential weak points in ZIO 1.0's construction. I've certainly taught a lot of coworkers how to use ZIO. I basically bring it up to people in the grocery line, even though there are no grocery lines anymore, but I would if those existed. And I try to convince them to use ZIO because I just love it so much, in a non-biased way, of course. And one of the problems that I've experienced is, people have a great time with the as a replacement for futures, right? The power of parallelism. I mean, it takes a little while for people to even adjust to their the length of their lead being extended by like a few miles. There's sort of some learned helplessness, things that you're not even going to try in the world of future. You sort of slowly realize, wait a second, I'm no longer bolted to like a 1 meter a rope around my neck. I can go wherever I want. But there's some issues. There's some problems with the current patterns and constructions that we're teaching, and we're going to go over that. We're going to start with just a ZLayer rundown because some of these do concern ZLayers, as hinted before. So just a brief overview, a little fancy visualization for funds about ZLayer. And then we're going to reckon with real-world feedback and do some alliterative introspection by taking a look at some of the flaws, frictions, and failures of ZIO 1.0, and then synthesizing that introspection into API perfection, modulo hubris, and coming up with the perfect API forever and ever. And hopefully dealing with all those problems. In fact, we're going to do these in 3 separate cycles. We're going to look at a problem and then talk about how we're going to attempt to address that in ZIO 2.0. So let's get started with ZLayer overview. What are they? So at the very high level, because there are lots of things, they're powerful. They could be used for a lot of things, but I think the most common way is to structure non-trivial ZIO applications. So literally, these are the data structures that you use in tandem with a certain pattern known as the service pattern that we're going to get into as well for structuring your ZIO applications. They are also composable recipes for building your app services. So they're these modular, pluggable little descriptions, these value objects, descriptions just in the way that ZIOs are, for composing your application's internal dependencies. So you build your dependency graph, not the Maven dependencies, but your services, your user service, your repository, and it lets you swap out in sort of this plug and play, composable, modular, different versions of your implementations, right? So you want to code to interfaces, and ZLayers let you really nicely compose these together and swap out a test implementation with a live implementation, and then provide the transitive dependencies of each of those implementations in this really cool way. That is, there's a bit of a learning curve, but it is incredibly powerful, and we're going to work on the learning curve part. And of course, these are asynchronous, just like ZIO, resourceful. They can acquire and release resources, and they can fail and be retried, and they're first-class values. And unsurprisingly, it's because they are implemented in terms of ZIOs and ZLayer primitives. So let's take a look at a contrived example. So here we have this URIO, URIO, which is a ZIO that just can't error. So this pattern, whenever you see it, the U means unexceptional or unerring. There is no error. R generally means there's some environment. So a URIO you can think of as a function, sort of. It's like a ZIO equivalent of a function. Anytime there's an environment, you can, in your head, have a mental model that these are sort of functions, right? The requirements are kind of like the inputs to a function, and then the A parameter, the output, is the return value of the function. So here we have this old lady function, which is certainly a contrivance, as advertised, which will do something. It's going to return units, so this is going to have some side effects. And in order to do that, it requires an old lady. So we must give this an old lady. Just we have to call a function with an old lady. So how do we get one? Well, we're going to use ZLayers. And the same pattern is nicely shared throughout the API. I like that consistency. It's very helpful. Once you learn it, you can reuse that knowledge. It's transferable to the entire ecosystem. So a ZLayer that does not error, has an input and an output, is a UR layer. So once again, the same metaphor applies. This is sort of like a function. So here we have an old lady layer that will get us an old lady, but this has its own input, its own transitive dependency. If we decide to use this particular layer to get ourselves our dependency, then we're going to have to provide it its own dependency and so on. So this requires a fly, which itself takes a spider, and then that spider takes any. And any is sort of the type level equivalent of no input needed. It's a nullary function, or it's a, well, you can think of it as unit, even though unit's another type. But yes, this is due to contravariance and reasons that we're not going to get into. Read any as the environment to say this can run in any environment. This has no particular constraints. This takes no arguments. So we've fully satisfied the environment. And we're going to use a little bit of visualization just for fun. We'll get into this in just a minute. And our goal is to build a layer that returns ourselves an old lady and that has no dependencies. That is a fully satisfied layer. And then we're going to provide that to our program, getting ourselves a fully satisfied program, which then we can then run using unsafe run. So how are we going to do this? Well, we're going to start with our old lady layer, but this does not compile because it requires its own transitive dependency, which is a fly. Luckily, we have the fly layer, so we can use this, and we can use this vertical composition operator, these 3 arrows, to compose the 2 layers together, providing the output of the one on the left into the one on the right. Now, you can think of this as a graph, so there's kind of a graphic representation below, but obviously in code, everything needs to be laid on its side. So down here will hopefully help you understand a little more the structure of what's happening. I think that's one of the confusing points is we're sort of taking this graph idea and then having to flatten it into code with parentheses, and it can be a little confusing sometimes. Then we need a spider. So there's a spider layer. We compose that, and now all of our dependencies are satisfied. And now we can run this effect. And this is going to visualize this resourceful aspect. ZLayers are acquired from the leaf nodes up to the top in the order of their dependencies as maximally parallel as possible, even though in this case, everything is dependent on its child, so there will be no parallelism. But we'll see that each of these effects has an acquire. So they'll each be required up until the top, then the effect will be run. And then once that effect exits, they will be released in reverse order. So we're going to visualize what I'm talking about right now. So spider is acquired, fly is acquired, old lady is acquired, the effect is run, and then they are released in reverse order. So that is actually simulated using ZLayer and ZIO using Scala.js, which I like a lot. I gave a talk about that at Functional Scala 2021 if you want to know more about Scala.js, but it's a good way to simulate ZIOs, to use ZIO. There is also horizontal composition. So what if you want multiple inputs? How do you handle multiple inputs to a function? We're going to use the same program, this old lady celebrate function, but this old lady, we're going to provide a different layer. You could do this. Generally, you do. Generally, in ZIO in production, you have a live layer for production. I mean, you can have as many as you want, but the ones that you see often are a live version and then also a test version, where there are probably less transitive dependencies, or maybe just it uses an in-memory ref or maybe STM to mimic the API in a testable way. But this one has 3 dependencies. This hungry old lady wants a burger and a biscuit and beans. And luckily, we have the 3 layers there. So how are we going to do this? It's the same goal, to provide a layer that returns the old lady dependency and has no dependencies at the end. So it's a fully satisfied layer. So we're going to take the old lady layer, This has 3 dependencies. So first, let's just start with the burger, still not compiling. This has no dependencies itself, any there, so that's fully satisfied. And then we're going to move on to biscuit. And we're going to use the horizontal composition operator, which is plus plus. And what this does is it takes the respective outputs of the 2 layers combined and withs them together. And this will keep happening. So we're just going to with that, and we're going to horizontally combine beans. And now we're fully satisfied. And this compiles. And if we run it, we'll see that parallelism aspect at play. So let's see. The leaf nodes are all acquired in parallel. Hungry Lady layer is run. And then the effect is run. And then they're all released in parallel as well, which is super cool. That happens for free when you use ZLayer. It's really pretty neat. So yeah, that's that. Let's move on. Obviously, this can get very complicated, but yeah, that's kind of the overview. So let's get into the reckoning. What have we learned from teaching ZIO to our coworkers, our friends, people that we meet on the street? What have they struggled with? And let's start with this thing called the service pattern, which is this semi-documented pattern. This thing has evolved slowly. It changed when ZLayer came out, which was a beautiful thing. But there's definitely some confusion. But what is it now? Well, currently it's an object. It is a nested service trait that has the actual functionality of whatever that object is. So the object has the semantic meaningful names. This is some analytics service with a track function. It can track different events. And then there is a type alias with the same name of the object, the meaningful name, which is alias to has service. There are some accessor methods. These can be generated by an accessible macro in the ZIO macros project, but I'm just including it here for fullness. And then there are the layer definitions. You can define these anywhere, but it's nice to have them on the companion object just for discoverability purposes. Generally, live is the sort of the de facto one for production use. And this pattern is followed internally in the ZIO library. So just looking into the ZIO code base is a great way to learn about, well, Scala in general, but also about ZIO patterns, because they try to dog food their own designs. But we're just going to focus on these 3 aspects: the object, the nested service trait, and the type alias. So why are we doing this? Mostly for aesthetics at the call site. So when we have one of these ZIOs that we can think of as a function, we want to be able to read the multi-argument nature. So here's a function that takes 3 inputs. We can think of it as semantically. And we want to just be able to read those inputs in this nice readable way. Obviously, these are all type aliases. So if we didn't do this, they would all have to be wrapped in has, which is an extra 5 characters per layer, which is 15 characters in this case. And that's why. Maybe you're having some thoughts now. Okay, but let's talk about what's bad with this. This is weird. This is not something you would just stumble across, right? You wouldn't just find yourself doing this maybe naturally. The gains are not really evident inside of here. This is mostly developed. I mean, it's good intention for sure. When in examples you want it to look readable and nice, you don't want to have this has word there cluttering things up. But it's a strange pattern. It's hard to teach. It's something else on top of other core concepts, which are very important to learn, like what ZLayers are. What ZIO is. There's already enough to learn, and then there's this other aspect of this type alias here, which is just non-standard. It has problems. So one of the great things about ZIO is that you can incrementally introduce it to a code base. It's not very opinionated. Well, it is opinionated, but not in terms of its integration. You can use it in the small, you could use it in the large. It works great for introducing. I've done this basically at every job I could possibly do it at. It doesn't have like some global config file, right? It's not like play, which is going to corrupt everything you touch and be really difficult to extend. So if you're using it in a code base transitionally, you're probably not going to convert every trait in your code base over to the service pattern right away, which means sometimes you'll have the alias, sometimes you won't. And just by reading the type signatures, you won't be able to tell what is what. Even if you're completely principled or start from a big bang rewrite and do this, it still can be confusing. But generally in practice, what people tend to do is they tend to wrap things in has twice or not at all. And this gives some gnarly type errors and people just get confused. I've been seeing this sort of everywhere lately, especially since making these changes, whatever the Boehner-Meinhof syndrome. It just shows up everywhere on Reddit and Twitter and the company's Slack. Like people are confused about these type errors. Okay, and then there's aesthetics as well. So it's not even a complete gain on aesthetics, because now to refer to the actual service, you have to do dot service, and this is weird. This is not quite standard, and it's also more code. In fact, it's a net loss of characters. This is 8 characters to type. This gets de-aliased as well in type errors, which adds even more noise to what is already quite a noisy type error. It's so it's not even a gain on the front that is it the only place it wins. It kind of still loses. And then there's this boilerplate. We have to type more code, and then just like why are we doing this, right? I did explain that, but nonetheless, it's easy to think, why is this worth it? And I think the answer is no, it is not. So take a mental snapshot in your mind's eye, and let's take a look at the service pattern for 2.0. It's probably not even really worth calling a pattern necessarily. This is a trait with a companion object. This is not weird. This is standard Scala. This would happen automatically. This is probably how your code bases are already organized to some degree. And yeah, it's fine. There's an explicit has. Okay, we have to deal with the extra boilerplate, but this is an important concept to learn about. It's part of ZLayers implementation. It gives you a lot of power. It's a fascinating implementation. Definitely recommend looking into that. It's a really, really cool data type. And yeah, it's going to, I think cause less headaches in the end. And then aesthetically, we no longer have to refer to the dot service anymore. URIO has analytics of analytics. Okay, we know what is what here. That is a tremendous thing. I didn't even realize after switching to this new pattern just how much anxiety was kind of caused with just not knowing what something is at any point. It can, you get a little scared of your own code. Here, you know what's in a has, you know what's not in a has. It's quite nice. There's no boilerplates. Why not do it like this? When you look at it as a whole, this makes a lot more sense. And so we're going to be switching over, as I mentioned, the internals of the library to use this pattern. So to sort of back out the type alias pattern, and I recommend other people do this as well, because it is just easier to deal with. It's more teachable, it's simpler, and it works just as nicely. Okay, that's just kind of a syntactic thing. We're going to get more towards exciting things as we go. There are 2 more of these little issues. So the next one is defining ZLayers. In 1.0, let's take a look at this. How do we do this? How do we do the live implementations? How do we write our different ZLayers? Well, there are some functions on ZLayer. John also mentioned this in his introduction. There are a few of them, from function manage, from function many m, from function many manage, from manage many, from service many manage, from services many managed. It's these series of tongue twisters. And then many of these also are overloaded. So multiply each of these by the magic number 22. And when you type ZLayer dot, your autocomplete explodes and IntelliJ crashes. That doesn't actually happen, but it actually can slow down for autocompleting some of these. And most of all, you just have to scroll through it. You have to basically know what you're looking for. And they all differ very subtly. They're hard to read. There are all these slightly different naming conventions. Okay, so how do we use a few of them? Let's just take a look at a progression of 3 examples. So if we want to build one of our analytics services, here's the 1.0 pattern again. So we have to chain on dot service. We can make one from another service. So we might want an analytics service that just dumps events into the console for whatever reason. And therefore, we want to depend on the console service. So we could say ZLayer from service, console, annotate the type, and it'll figure out what it needs to do, and then define the service in terms of the other service. And then this will return to us a UR layer with both types wrapped in has, which will then be the type aliases, which is nice. Okay, what if we want multiple services? So here we want to add a random UID or an event ID to each of these events for whatever tracking purposes. So we're going to also rely on the random service. Well, now we weren't able to just actually add another type annotation to our function. We had to annotate everything. This is because of a bug in Scala 2, unfortunately, but it really bites you when building complicated services, because the sort of the shape of these functions has to change significantly between the just different arities. So yeah, that's painful. Next, what if we want to also use an effect inside of here? So we want to make some ref that will track the last time each event was dispatched. So we can do that. And then we're inside of our from services M now, we're going to have a ZIO effect and then yield the service from within there. So we have to use this other type parameter. We have to specify even more things, the environment of that inner effect, its error, et cetera, et cetera. It gets really verbose. The order very much matters. There's so many type errors that can happen here. And if you want to change between the two of these, it's just a whole lot of pain and work, especially with the number of overloads. How do you even know which one to use? You basically have to memorize the API first. It's quite painful. So what do we do for ZIO 2.0? As John also implied in the introduction, we're going to just delete basically all of them, or most of them at least, and come up with a better way that is more consistent, a pattern that leverages existing ZIO knowledge, and just teach that, document that, use it internally in the code base all the time, one that is extensible. So before that's a little bit of background. The ZIO.service function, this takes a trait. This is now the 2.0 pattern, so we can get the explicit has's. It's nicer, it's shorter. So we're going to take this analytics trait. We want to grab this out of the environment. This is kind of sort of like an identity function, except that it requires an environment that has the analytics, and then it'll just pull it out for you and return to you a ZIO that depends on has analytics, gets the analytics. And then, if you ever have a ZIO, whenever you have a ZIO, there's a two-layer function on it. And then all this does is just takes the output type, lifts it into a has, and then propagates the environment, which is nice. So here we kind of have an identity layer for analytics. But this piece of information is going to be quite useful. Let's take a look at re-implementing each of these in this new pattern. Okay, here's the first version that we saw before, ZIO 1.0 version, and then we're going to translate this. Not a clear win off the bat. We'll see why this gets better. But first, what we're going to do is just use this new ZIO, well, not new, but old ZIO.service function with the console, grab the console, and then provide it to a live implementation. Now, we could have done this before too, but it wasn't necessarily used consistently. We're going to document and recommend pretty much doing this all the time. Make a case class for your implementations. Accept as arguments all of the transitive dependencies they require, as well as any other arguments that they need, and then extend the traits, and then implement your services in there. Much more readable like this. I mean, this is also a pattern that you see this in non-ZIO code as well. You have the traits and you have implementation versions, even though you might use some horrible library like Juice, and you'll have all these inject annotations on your implementations. But yeah, that's this. We use ZLayer at the end, which will propagate the has console into the ZLayers dependency, and it'll lift up this analytics into a has as well. So we get a layer. Same thing. Maybe not a clear win yet, but when we start accepting multiple arguments, and if things start getting more complicated, let's compare this. All that happened here is we added another line to our flat map. We didn't need to change the function name. We didn't really need to do anything differently. It's completely extensible. We accepted another parameter into our case class. We added another line to our flat map. Pretty regular, pretty teachable. Next, the really gnarly one. How are we going to handle this? Surely this is going to get really wacky and ugly. No, it is the same. It is the same exact pattern. We add another line to our flat map. We can use ZIO effects. We're already in a ZIO, and we just pass these along to our constructor. It's a nice, regular, teachable pattern. When you look at all of these side by side, they just get longer. They don't have to fundamentally mutate or change form into some horrible construction. So you learn it once, and you can build layers whenever and leverage the existing ZIO knowledge. These are all just ZIO functions. We just turn them into layers at the end, which is nice. Also, as we looked at before, ZLayers can handle acquire and release effects. So say when we wanted to shut down our analytics service once it was used at the at the top level of our application, it needed to connect to something. Here we're just going to console log shutting down. Well, how do we do this? Well, there is already a toManaged function on ZIOs, even though this might become toManaged with it looks like in ZIO 2.0. And then we just pass along the function shutdown, and then convert this to a layer because ZManaged also has a two-layer function. So it's the same knowledge. You get to reuse it everywhere. You don't have to memorize a slew of 100 different convenience methods that will all give you weird type errors. And yeah, it's just consistent. So that's defining layers 2.0. And lastly, using ZLayers. So this is live coding time. Wish me luck. Here we go, entering the dojo. This says dependency injection 1.0. Okay, yeah, it's hard to read my ASCII font here. So dependency injection 1.0. So here we have, just like we started with, a program, and we want to satisfy its input, which is this conference service with an email service with a console. And this is ZIO 1.0, so these are all has aliases of services. And so we have to call provide layer, returning ourselves a layer that does this. So let's just start out. We use the service pattern. So I'm going to say conference service .live. And then we're going to use our horizontal composition to compose this with an email service .sendGrid, the implementation. And also, a live console. And now when I save this, we're going to unlock ourselves a horrible type error, which if you've used ZLayers, you are intimately familiar with these. And generally, I recommend to coworkers, just take this as a symptom of being a problem. Do not use this to well, this is like a diagnostic. There's something wrong. Generally, you haven't provided everything that you require. Just look at the line number and investigate things manually. It's kind of unfortunate, but it's way better than parsing this manually. I've seen people copy paste this and try to align the different services to figure out where's the diff. That's really hard to do. Generally, what's happening is that something is missing, and I know that for a fact. So conference service.live is missing its own transitive dependencies that we need to provide to this. So we can just wrap this in parentheses. And I think this is needing an analytics.live as well as a conference repository.live. And we can do this. And now if we save again, there are more type errors. Because it still isn't matching, because these have their own transitive dependencies. Generally, at this point, what I recommend doing is pulling these out into their own intermediate variables, so conference service layer. And then we can type this explicitly, and we can see that, yes, indeed, this one still needed a database. I know this came from conference repository live, so we can then break this out into its own function, so on and so forth, just to keep things organized. Now, I've already done this. So layers.full layer. And this should, this does compile now. We can take a look at what this looks like. This is basically the best you can do. We have a bunch of ZLayers, which have no dependencies. They're just the outputs. This is sort of a little visual representation of what we need. So starting from the top, we need a conference service, email service console. So these are joined together, conference service layer, email service layer, console. And each of these recursively do the same thing with their own dependencies. So conference service.live needs conference repository and analytics.live, which has its own dependencies, and so on and so forth. So you build the tree, you get to localize the errors this way, but it's still kind of painful. And the second you screw something up, like let's say to conference service.live, we added a geolocation dependency and then saved again, we're going to give ourselves that horrible type error. It's going to be a little better if you localize it. But in practice, a lot of people don't do this, and they even use this other operator, which is I'd like to call the car crash operator, which just outputs all of the dependencies as well, and you can kind of just make everything into just one giant file. If you do this, the second you introduce a dependency, your type error is gigantic. And generally, the person who knows the most about ZIO and ZLayer is called in and has to help everybody. That was certainly my case. Every other day, helping people set up their ZLayers, resolving their errors. Super painful and not very fun, and a pretty bad experience for something that is so wonderful. I mean, I would deal with this boilerplate. You can get good at this. You can figure this out, but it is not fun anyway to deal with these errors. And it does ZLayer disservice because ZLayer is so beautiful and powerful. So dependency injection 2.0. What is this experience? So first of all, provide layer. Oh, it's deprecated. We're going to piggyback off of, people hate name changes, but I think it's important to name things in a way that's going to help more people understand them. And there's this dependency injection metaphor. So we're going to try calling this inject. Same deal, it compiles. But let's delete this. This is using that same exact pattern as before. So this is just the same exact layer that we had before. Let's delete this. And let me hit save. And try again. Okay. So we see here an error output that says exactly what we're missing. We're missing a conference service, we're missing an email service, and we're missing console. And luckily, because this is no longer using the service pattern, these are more readable. There's not the dot service at the end of these. So how do we do this? Okay, let's do the same thing. Conference service .live. Actually, let's start with console.live. Let's just make sure that we're not hallucinating and this makes sense. So can we satisfy this dependency? I save. Console has disappeared from the missing outputs. What if I add email service .live, or .sendgrid rather? We have now unlocked the transitive dependency for this implementation of email service. So we require now a SendGrid config for our email service.sendgrid. We could use a test implementation of email service, and there is no dependency. So we kind of go transitive dependency by transitive dependency, working with the compile errors. So I'm going to say SendGrid config.live, and this needs some kind of token. I'll do a bunch of vowels. And yeah, now conference service.live. Let's keep going. Conference service.live. Unlock some more transitive dependencies. Analytics.live. Conference repository.live. Okay, this needs a database. Database for our conference repository. Blood for the blood god. Database config. some database config dot. Do I have a live? I may have typed something. Oh, I don't have a comma. It cannot add commas for you. That is on Scala. Okay. And now it compiles. Yeah, that's, I would say, a much better experience. The order doesn't matter. You can put these in any order you want. Basically, this is a compile time macro that's going to generate the same exact code as it did previously. It's going to generate something like this, except in Scala versions with the pluses and the arrows. It's using the ZLayer infrastructure on the inside. You can still use compose ZLayers as you would, otherwise. Like, for instance, I could just make this plus in here and provide that directly if I wanted to, and that's going to work all the same because this returns a layer with the right dependencies. So it's really nice. It infers what it needs based on the program. You can just also derive these yourself with a ZIO.wire function. ZLayer.wire function. And then with this one, though, you have to pass in the target. So I could say conference service is what I want, and I can just directly build the layer. And then when I save this, it's going to tell me, okay, you need a conference service for this, and that will unlock the transitive dependencies as well. So you can just build the layers directly. You can also leave off particular inputs. So if you want to leave a remainder, that will also work. I don't have time to get into all the overloads, but this will be documented, and it's pretty cool. One fancy thing that I like, there are all sorts of helpers that we can add. There are a few that I've already added. So let's say if I go to my, let me break this back out. I don't think that matters, but let me break this back out. And let's add to database. What if we screwed up and somehow we ended up with this having a dependency on conference service? Well, this would be a circular dependency. Database.live both requires and is transitively required by conference service.live. So that's a nice thing to help you. There are all sorts of little things like that as well. If you leave off the has, it's going to tell you this contains non-has types database config. So even though we are removing the type alias, we can help you out still. And there are probably many other things we can adapt. Embracing a little bit of macro magic is going to be quite nice. And just for fun, this may not make it into production because it's mostly good for demos. But what if we wanted to visualize what we've built here? Okay, inject debug. This is the graph that it's built. This pretty much mirrors what we've done here. Conference service.live, taking these dependencies and so on and so forth. It's kind of fun. It's kind of silly. Obviously, if I shrink this, it's going to look horrible. But we have a lot of opportunity here to do some fun things and to, I think, pretty much remove all of the pain that has been caused. There should be a drop-in replacement modulo the renamings, which there should be Scala fixes for. And that's basically it. If you want to use this now, there is that ZIO magic repository that I referred to as well. That will be for ZIO 1.0, though I've done a lot of work for the 2.0 version. It's a first-class citizen. You won't need an external dependency maintained by one person. But if you want to use that, that would be great for just some production feedback. I'm going to use some feedback there to make sure that this is completely robust, though it's already been used in production. Scala thought leader HMemCopy, Egal, has been a great help bringing that into his company and giving me a lot of great minimized error reports. So I'm pretty happy with how it is now. But yeah, I'm very excited about this. I hope this makes life way easier, and ZLayer, which is amazing, easier to use. So yeah, thanks for listening. We can go, it would be great if people are curious. If people want to work on this with me, I am happy to do a Zoom and talk about how macros work. I never wrote a macro before this. I was going to just procrastinate until Scala 3, but this seemed like such a compelling idea that I sort of tricked myself into doing it, and it wasn't that bad. So I'm happy to do a Zoom some other day with anyone who's interested if you want to help out. So I am over now. Thank you so much. That was amazingly fun.